Myself, Benilda, Assistant Professor in the Department of Artificial Intelligence and Data Science at Sri Muthukumaran Institute of Technology. Today, we are going to learn 3D printing and design. The subject code is CCS 331, Regulation 2021. In previous videos, we have seen extrusion-based 3D printing, wire-based 3D printing, and granular-based 3D printing. In this video, we are going to learn about lamination-based 3D printing. Lamination-based 3D printing builds objects by stacking and bonding thin sheets of material layer by layer. Each sheet is cut to the required shape and then laminated to the previous layer using heat, pressure, or adhesive. This lamination-based 3D printing is also known as laminated object manufacturing. Here the materials such as paper, plastic, metal, or composite sheets can be used. This method is fast, cost-effective, and suitable for making large parts through it usually require post-processing to remove excess material. The lamination-based 3D printing works by building a 3D object through the bonding and cutting of thin material sheets. Here we can see the working principle of lamination-based 3D printing. First, sheet feeding takes place where thin layers of material such as paper, plastic, metal, or composite sheets are supplied to the build platform. Next is layer bonding. Each new sheet is bonded to the previous layer using heat, pressure, or an adhesive, ensuring proper attachment and alignment. Then layer cutting is performed. A laser or cutting blade cuts the bonded sheet according to the cross-sectional shape of the digital 3D model. After that, the layer stacking continues. The build platform lowers, a new sheet is added, and the process of bonding and cutting is repeated layer by layer. Finally, the post-processing is done. Once printing is complete, the excess material surrounding the part is removed to reveal the final 3D object. Next, making process of lamination-based 3D printing. Here, the process are material preparation, layering and bonding, cutting, repetition, and post-processing. You can see it in detail. This lamination-based 3D printing builds parts by stacking and bonding thin sheets of material such as paper, plastic, or metal. First, the thin sheets are prepared and placed on one over another on the build platform. Each new sheet is then bonded to the previous layer using adhesive, heat, or ultrasonic welding, creating a solid laminated block. After bonding, a laser cutter or sharp knife cuts the outline of the required shape for the particular layer based on the CAD model. The unwanted material remains around the part and helps support it during printing. This bonding and cutting process is repeated layer by layer, gradually forming the complete three-dimensional object. Once printing is finished, the extra material is removed and the part may undergo post-processing such as sanding, painting, or surface finishing to improve appearance and accuracy. Next, this diagram shows the working of laminated object manufacturing system. This laminated object manufacturing is a 3D printing process that builds object layer by layer using thin sheets of material such as polymer-coated paper or plastic. First, a 3D model is created in a CAD software and sliced into many thin layers. A sheet from the material roll is placed on the build platform and a heated roller presses it so the adhesive coating bonds it to the previous layer. Then a laser controlled by an XY system cuts the outline of the required shape for that layer while the extra material around it cross-hatched into small squares to make removal easier later. After cutting, the build platform lowers slightly and a new sheet is added and bonded. This cycle repeats until all layers are formed. Finally, the cross-hatched waste material is removed, revealing the finished 3D object inside. Next, the most common materials used in lamination-based 3D printing. Here, first of all, paper, the most common material allowing for full color, wood-like or aesthetic models. Next one is metals, used in ultrasonic additive manufacturing, which uses ultrasonic welding to bond sheets of aluminum, copper, or titanium. Then composites, used in composite-based additive manufacturing to create high-strength fiber reinforced parts. Next, the types of lamination-based 3D printing. So, laminated object manufacturing and ultrasonic additive manufacturing. So, what is LOM? That is laminated object manufacturing. It is an additive manufacturing process where thin sheets like paper, plastic, or metal foil are stacked, bonded, and cut to form a 3D object. What is ultrasonic additive manufacturing? That is UAM. It is a solid state metal 3D printing process that builds part by ultrasonically welding thin metal foils layer by layer. Next, key techniques. In additive manufacturing, key techniques are the primary 3D printing methods used to build parts. So, the first key technique is laminated object manufacturing. This LOM builds part by stacking and bonding thin sheets of material such as paper, plastic, or metal foil. Each sheet is laminated using the heat or adhesive, then cut to shape with the laser or blade. Layer by layer, the 3D object is formed while the unused material acts as a natural support. It is fast, low cost, and suitable for large prototypes, but surface finish and fine detail are limited. Next one is ultrasonic additive manufacturing, UAM. It creates metal parts by ultrasonically welding thin metal foils together using pressure and vibrations. The process occurs at low temperatures, reducing residual stress and distortion. CNC matching is used between layers for accuracy. It is ideal for metal components with embedded sensors or electronics, especially in aerospace and defense. Third one is composite-based additive manufacturing, CBAM. This fabricates parts using composite sheets made of fibers like carbon, glass, and resin. Sheets are cut, stacked, and bonded layer by layer to form strong, lightweight components. The fiber orientation can be controlled to improve strength and stiffness. CBAM is commonly used for structural, high strength and lightweight applications. Next advantages. Speed and cost is generally faster and cheaper than other 3D printing methods using standard material like paper. Then regarding size, it is capable of creating large parts. Then no support structures where excess material acts as a support. Next, the limitations of this lamination 3D printing. Geometry complexity, strength and post-processing. So these are the limitations. Its geometry complexity it is not suitable for complex internal geometries. Then generally it is not suitable for the functional structural parts. Then it requires many removal of the cross-hatched material. The next one is applications of lamination-based 3D printing. Packaging and prototyping. This lamination-based method like LOM are used to quickly create low-cost physical models, and they help designers visualize size, shape, and fit before final production. Next one is industrial manufacturing. It is used for metal component fabrication because it joins model foils without melting. This results in strong parts with low distortion, suitable for aerospace and industrial use. Next one is architectural models. It is ideal for large-scale architectural prototypes. It allows fast construction of building models and layouts at a low cost. Finally, medical and electronics. This enables embedding sensors, wires, and electronic circuits inside metals or layered structures. This is useful for medical devices, smart components, and electronic housing. So this is about the lamination based 3D printing. Thank you.